Hi everyone, my name is Jordan. I'm here to talk about smuggling data between PowerShell processes like Han Solo. I've had a brief conversation before that I'm saying data wrong, people say data, but you're just going to have to get used to that because that's how I say data. Just before I begin, a quick thanks to all our sponsors here at this conference. Without them, we wouldn't be able to be here and hear all these fantastic talks. I highly encourage you to have a talk at their booths tomorrow, below and see what it's all about and just have a look. So my name is Jordan Borean. I'm a software engineer from Red Hat. I work on Ansible and I specialize on the Windows integrations. So do a lot of things with PowerShell. And then I just enjoy working in Python, PowerShell, C#. If you like, there are seats at the front here. There's plenty around. You don't have to stand around, or you can stand there if you like. It's entirely up to you guys. I've got a few PowerShell modules that I work on. Mostly it's just stuff that I've built for my own purposes and what I use it for. And I'm fairly regular in the PowerShell Discord, which I highly encourage for people to join. It's a fantastic place to learn PowerShell, see what other people are doing, and just understand new things. It's probably the best thing that I've ever done for my PowerShell knowledge. I've learned a hell of a lot from there. So, basically, when you're running processes in PowerShell, probably people know there are 101 different ways of starting processes. You've got starting it inline, like just PowerShell command and then ... the script that you want to run. You can do PowerShell and then using your script block braces, you can put your code in there. That's what we call, that's what PowerShell calls a mini shell. There's a few extra things I'll show you what it can do a bit later. You can use start job, which starts a new PowerShell process and then it runs the script block that you provide with any arguments. You can use start process to run things in the background or even wait for it. That's a bit more advanced and it's hard to get data back from that one there. You can use schedule tasks to start things using other users, add a schedule in the background, whatever you want to do. There's also a whole bunch of other executables, maybe not included in Windows, like PSExec, a whole bunch of other ones, and I'm probably missing a whole bunch of things like WMI and other things like that. So the problems when you're doing that one there, how do you specify what to run? If you're just running PowerShell processes using like PowerShell commands, you're going to come across quoting hell. So how do I escape these double quotes so it can be processed by the shell? If you're running it through CMD, then PowerShell and a whole bunch of different layers. You have to escape it for each different layer, and that gets messy really quickly. You have issues like command line length limits. I think Windows has maybe 32 kilobytes of data, which sounds like a lot. But when you're passing in big scripts, a lot of arguments, or very complex data, you're going to hit those limits quite quickly. Another option with PowerShell is the encoded command argument, where you can base 64 some text. That deals with a lot of your quoting problems. But I found in my course and what I've seen people use, a lot of antiviruses seem to hate encoded command, and they'll actually block your process from running, or it will trigger some security scans where your security team will call you up saying, hey, what is this? What are you doing? Another option that you can do is just use files and put a script on the file system and say, hey, PowerShell, run this script here, which is good for most cases. But you may accidentally sort of embed secrets in there that other people can access. There's a few sort of gotchas that you have with files. The other issue is, how do you protect the secret? So I want to pass a password to access like an API key or something like that to the script that I'm running. How do I securely pass that to the child process so logging can't pick that up? There's 101 different ways in PowerShell to log the data that you're running. So that's a very important thing to be careful of. There's also more advanced things. I want to run this script as another user. So I've got this credential, username, and password, but this script or this process here needs to run as that user and not me. Also, if you're doing WinRM, PowerShell, SSH, remoting, all that type of stuff, a very common issue that I've seen is sort of the network logon. So you can't run Windows updates on a network logon, or your general double hop credential delegation issues. I want to access this file share, but it doesn't have your credentials to do that. How do you deal with that in PowerShell? So I'll go through some examples for this one here. I've written a very basic proof of concept tool called Secret Sniffer. In this case here, it's got a whole bunch of built-in ways of trying to extract secrets from PowerShell processes that are actually running. So the four main ones that I've written are command line auditing. What that will do is it will enable the command line auditing setup on Windows, which will log all the processes that are running as well as the command line that it's running with. You do need admin for all this stuff here, but a lot of organizations I've seen do have this enabled. So it will show how you can embed passwords in the command line and how this one here can pick it up and store them in your event logs. There's process environment variables. If you're storing a password in an environment variable, other processes can detect that information and extract that. Once again, it does need to be admin, so it's not an actual exploit, but it's just something to keep in mind of when you're running in an environment. Module logging is probably a lesser known version of logging in PowerShell itself. What that one does is it can log all the parameters and their values of certain commands in the modules that you're running. So this is a very verbose logging setup in PowerShell itself, both for Windows PowerShell and PowerShell 7. And this one here can get a lot of detail if you're logging specific commandlets like convert to secure string. Finally, there's script block logging. This one here is probably a bit more common. Maybe some people have heard of this one here. Essentially, this one here will log all the script blocks, so scripts that you're running in PowerShell. One of the caveats for this one here is that you don't actually have to have this enabled for certain script blocks to be logged. I'll show you a bit later, but PowerShell will log what it considers suspicious script blocks, even if you don't have this one enabled. So this particular example here, I won't enable script block logging. It's to demonstrate how these logs might contain some information you don't want to be logged. The two key points as well for the module and script block logging, PowerShell doesn't actually secure that for admin users only. So if you're logging any of this information and you have a standard user on the computer, by default, they're able to see these logs. So they're able to see the scripts that you're running. If module logging is on there, they'll be able to see the commandlets and parameters that you might be running on there. So that's something to keep in mind of. There are a few docs online that allows you to encrypt this data as well as sort of secure it so you can only allow admin users. That was actually a cause for a CVE in Ansible where we were accidentally logging some secrets and we weren't aware that it wasn't admin only, it was all users on the system. So in this case here, I'm going to enable this. I'm just going to put in a pattern to search for. So in this case here, it's just password. So tell me if you find any command lines, environment, script blocks, module logging that contains the string password. So I'm going to run this one here, and this is going to run this TUI in the background. It uses PowerShell Spectre Console, which is a fantastic module. I suck at generating this type of stuff, but it was actually quite simple, and it was nice to actually play with something new. So the first example that I have here, I have a PFX file, and this is protected by a password. For whatever reason, I want to start a new process that's able to extract the subject from that PFX file. So in this first example here, what I'm going to do is I'm just going to put the password inside the script to run and run that through the standard PowerShell command. So if I do F8 to run this one here, we can see that we get the subject back, which is PSConference 2026 in Australia. Fingers crossed that happens. And then we'll look at our secret sniffer. We can see that this one here has detected 2 instances of this secret being exposed. So we have command line auditing. In this case here, it's detected that I'm running PowerShell.exe command, and I can see the variable and the actual password do not share being exposed inside this one here. So now we have an instance of our secret being exposed, and that's going to be an issue. We can also see that the module logging itself, I'm logging the convert to secure strings commandlet. I can see that the string value do not share has been exposed in this application. So we've also exposed this secret. So that's an issue. We want to try and fix that one there. So the next one that we want to demonstrate is script block logging. So I mentioned before that I don't have script block logging enabled itself. I haven't explicitly disabled it, but I've added this comment here that says properties. Properties is a keyword that PowerShell scans for, and if it detects it in your script anywhere, so this is in a comment, it's not used as a variable or anything, this is going to trigger the suspicious content, and it will log this script block. So I'll do the same thing. I'll run this line here. we'll see that we have command line auditing, that we'll have script logging twice because it's both where I'm running it here and in the new process. But we can see here that the full script block that we're running here, which includes the password, is now exposed. I don't have the logging enabled. It's going to be doing that because of that property in there. And then once again, we also have the module logging because the convert to secure a string commandlet. If we have a quick look at this link that I have here, you will be able to see the PowerShell code itself. If Firefox doesn't want to update on me, let's have a look. There we are. So this is loading here. We'll be able to see that there's a list of all the keywords that PowerShell uses to detect these strings. Let's make this a bit bigger because this is quite small. Close down some extra stuff. We can see things like add type, DLL import, create type, emit, methods, properties. A lot of these things here are sort of reflection based and some of the more advanced sort of malware type of techniques, but properties and methods is pretty common and might be existing in a comment. So this is something that I really highly recommend you look out for, because if you're having secrets in your scripts with stray comments on there, you might be inadvertently exposing your secret. So I would double check what's happening here and looking at your event logs. The next option that we have here is we're going to put this in environment variable and we're going to pass that through to the child process. So the script that we're running here doesn't embed the password inside that one there. The command line auditing won't actually pick up that one there because it's just environment my password, and it's going to pick it up through that process. So I'm going to copy these lines and run this one here. I do have an arbitrary start sleep 5 for this demo because if this process finishes very quickly, I'm not going to be able to pick it up straight away. But we'll see what happens. So we'll go back to our secret sniffer. We have two process environment detections. In this case here, it's the one that we're running in VS Code, as well as the child process. And we can see that it's picked up my password and then the value of that one there. So now we have our secret exposed. We have PowerShell script block logging has picked it up here. That's the one in VS Code. But if we look at our child process, we can see that while it has picked up the script block that's running, it's now been hidden by an environment variable. So that logging there won't pick it up. That's one way of avoiding this one here. Process environment stuff may not be great, but you do need to be admin to extract this information. So it's not the biggest issue in the world. It's not that bad. Command line, once again, we have the password just as being shown as the environment variable. So we're not exposing the password. And then module logging, yes, it does expose that, but this isn't enabled by default. This is just to show the amount of logging that PowerShell can do in your environment. So we go to our next example here. We're going to pass this one through standard in. So we're not going to use environment variables. We're just going to pass this one straight in. So we're going to have a string. We'll use the pipe to pipe it into the new process. And then we use the input variable, which will read the input and then pass that in to convert to secure string. So let's run this one here. Keep on pressing that. We can see that the script block logging, well, once again, I should have done something to ignore the VS Code stuff for the demo. But the command line auditing, we only see input in the variable, so we don't see the password. The module logging does pick that up because that is the actual value seen at runtime. So that one still will pick it up. Script block logging doesn't. We just see input. So it's not that bad. That's a pretty good example that we can actually use. Encoded command is another option that we have on there. And I mentioned before the mini shell that gets used when we're using these script blocks. We can see that we use PowerShell, then we use the script block brace, and we have embedded the password inside this one here. So we'll see what happens when we run it. So let's go back to our secret sniffer. We can see module logging has picked it up. Once again, it sees the value at runtime. The only way to avoid this is to have a secure string in the first place and not create it from a plain string. Script block logging, that's from VS Code, but this one here is from the process that has run. So even though the command has been encoded on the command line, it hasn't picked it up there. We can see that script block logging has still picked this one up here. So we still have an issue that we need to avoid embedding those passwords in there. So now, how can we do this to avoid all four of the detection methods that we've got here? Pretty much the main way that we want to do is that we want to read a secure string properly, so not embed that string as plain text. Either you can use the CLI XML, so export CLI XML, import. You can read host prompt as secure string. And then there's also the secret management modules with PowerShell, and there's a whole bunch of ones out there. I've got one for DP API and G. It's a bad name, but it is what it is. But there's things for KeyPass, Azure, and a whole bunch of solutions out there. So in this case here, I just have cert.parse, which we can see that this is an encoded hex string. On non-Windows, that will be plain text, but we won't talk about non-Windows for now. So we're going to load this secure string here. If we look at the value, it won't print, and we have to use some extra work to actually make that into plain text. So we're going to use start job here to spawn our new PowerShell process. We're going to use, the using directive for the variable to pull in our secure string from our parent process to the child one. So we're not using it as an argument. And then we're just going to do the same thing. Finally, we'll add receive job to get the output from there and see what happens. So make sure I've cleared out the detection. We run this one here. The job will run. We get our subject back. And we can see that script block logging has picked up something. Actually, that's the VS Code one. We can ignore that. But we can see that the job that has run has the password definition, but it's still that variable. So we don't have that plain text value that's visible. They can just see what the variable is called. We can see that command line auditing hasn't been triggered. The environment block doesn't contain our secret. And module logging, which has been detecting all the previous ones, hasn't been triggered because we have a secure string by itself and everything sort of works. If we're wanting to use the mini shell and not start job, there is an undocumented argument where you can actually pass in objects, including secure strings, to our encoded command. So in this case here, we have our script block. We're calling get PFX certificate, and we're just going to use the first argument provided. So the special source that's happening here is this -args and then our secure string object. And what this one does here is it will serialize them through CLI XML, and it will be able to make sure that that secure string hasn't become plain text and back again. So we'll clear out what's happening here. That's all good. We run this and we get our subject that's back there. And let's go back to here. It hasn't detected anything. So there's nothing in our script block one here because we didn't add that property. But even if it was, it would have just seen, hey, I'm using args0, not the actual value itself. So there's a whole bunch of options that we have available there. Like using start job and the mini shell is pretty good if you're providing discrete arguments. Some of the other ones isn't as great when you're handling secrets. So it's not that great. So let's go into the mini shell and sort of dig deeper into actually what's happening there, because it's quite interesting in what's actually happening. So I'm going to define some sort of helper functions to make some prettier output. You don't need this for actual running them. In this case here, what's going to happen if we just pass in a string? We can see here that this is a more complex string. We have single quotes and double quotes embedded on there. If you're trying to pass that through the command instance, for PowerShell 7, it isn't that bad because it will escape them properly. But if we're using PowerShell 5.1, we can see here that we've had to escape our double quotes here. If you're adding in more shells, like going through CMD or anything else like that, that can get messy very quickly. But we can see when we're using the mini shell, we don't have to worry about any of that there. It's just a normal string as you would normally see it in PowerShell. So if we run this example here, we can see that this is a string with single and double quotes. So it just works fine. There's no issues. We've got a normal script block and everything works great. We can pass in arguments as well that I showed before. So we're using that -args argument, and then we have an array of values. In this case here, I'm passing in a string value that has a space, so we don't have to worry about quoting or anything like that. It just needs to be a string. And then we're also going to pass in a secure string. I'm ignoring all the secret sniffing stuff that we're doing here by embedding a value in here. This is just to show you the mini shell and how things work. The script block itself has a param block, so it's going to associate argument 0, so the first argument, to path, and it's going to associate the secure string password to password. And then we're just going to output that one there to show it's able to get those values properly, and they are correct. So we can see that the path is our C program files with a space in there, and the secret has come across properly with the actual secret that we have decoded in process. So it works fine, and we have that secret in there. One thing we can also do is pass in complex objects. So these are sort of simple strings that we've been doing before, but now we want to pass something a bit more complex with properties. So we have a PS custom object with a path property that we're going to pass in as the argument. we can see that we can actually extract that. So arg0 is that argument, and we can get the path property from there like a normal object. We can also pass back objects itself. So we're not limited to passing it in. We can retrieve those complex objects. So in this case here, I'm going to run this and it'll be saving to the out variable. If we go out 0, we can see it's going to be C program files because that's this outcome of this output. And then out 1 will be our PS custom object here with a property. If we look at the property itself and we look at the type, it's not going to be a string, it's going to be an integer because that is what is defined in our PS custom object itself. So we have a richer way of exchanging this data without dealing with JSON or any extra work. PowerShell just does this all for you itself. One of the issues with this one here is that you do come across command line length limits if you're passing in a very large object. So for example, get process is a large object that has a lot of data associated with it. When it gets serialized, it's going to come across command line length limits. So PowerShell is going to fail saying, hey, file name or extension is too long. So error messages aren't great, but we have an issue with that one there. The only way to bypass that is to convert it to another one. So like using select string to extract the values that you need, or just sort of limit it by only passing in what you actually need. So let's have a look at what happens when we're using this mini shell. So PowerShell, when it detects a script block argument, so an argument that's wrapped in these braces, and you're calling in a native executable, what it does is it will convert that to a set of string arguments. It uses encoded, command, output format, and so on. I have this print argv executable, and all that does is it will output what the command line arguments are and how it's processed them in arg0, arg1, and so on. So let's run this one here. Make this a bit bigger. We can see that when we're passing in a script block with just the foo string, we can see that the command line length now has non-interactive encoded commands. We have a base 64 string, input format, and output format XML. So PowerShell has automatically converted our script block to these arguments. If we look at that base 64 string, we can go convert from encoded string, paste that one in there, and we can see it's the contents of our the script block that we have on there. All it is it's UTF-16 string encoded to bytes and converted to base 64. So that's just how encoded command works. So when we look at the arguments themselves, so if we do print argv with args, there's going to be nothing for the actual command that we're running. We can see that the args option now uses the encoded arguments. So we have encoded command, which is going to be empty, but encoded arguments is once again another base 64 string. This one here is a lot longer because there's a lot more information that we're passing in. If we convert this to a normal string, so convert from encoded string, we can see that it's a whole bunch of XML. Let's make this a bit prettier. Make this a bit bigger so we can see what's happening. We can see that this is a CLI XML string. So this is how PowerShell data is serialized as a string. We can see that we have two arguments. Oops, sorry. So we have a list which contains two entries. The first one is our object with our path property containing C program files. And the second object here is a secure string, once again with a an encrypted string value. So I can't do anything to decode this value unless I have the secret keys, which I don't actually have. So clear this one out. And then we can also see when we got those objects back, it was actually going to be a rich object. So how does PowerShell do that? So in this case here, we're going to output a complex object and a secure string, and we'll see what that looks like. So we have our command here. I'm going to use CMD to actually see what the output is when we run this with PowerShell. So if we quit this, open up command prompt, we go PowerShell, run this, make this a bit bigger for everyone. What have I done here? I have an equal at the end, so let's remove that. So we can see here, we have the CLI XML header that tells PowerShell all the data that's coming across here is going to be CLI XML, and we have our string value here. If we copy this and make it a bit prettier again, we can see the same thing. We now have two objects in our list. The first one is our complex object with the path property with that string value in there. And then we have a secure string output. So that's essentially how PowerShell deals with this mini shell. The only difference is that it's using a script block argument, but it really only matters when you're calling it with PowerShell, so PWSH or PowerShell.exe. So it's a nice way of very simply running scripts with complex quoting rules and other stuff like that. The issues with that is that you somewhat come across command line length limits. So we've gone through the mini shell and sort of the secrets. Let's look at some of the other options that we're trying to sort of avoid. One of the common complaints that I've seen with WinRM is that I cannot use the Windows Update API through PS Remoting or WinRM. The reason for that, I have no idea why Microsoft blocks it, but they do, so it's an issue that we have to deal with. But essentially, we have a very simple thing using the Windows Update API, the COM object, to get reboot required. So if I was to run this one here, it's going to complain saying, hey, you don't have access. So we have an access denied error. Why is that? I'm running as admin. So if I go, who am I all? Let's make this a bit bigger. We can see that I'm part of the administrators group. I'm enabled by default. So I am an admin. I should have access for that one there. If I was to run that one locally as the same user, let's run this one here. It works just fine. There's no reboot required. It's returning false. So the reason for that, as I was talking about before, is that when you have a network logon, which is what happens when you use PS Remoting, so SSH, WinRM, the Windows Update API says, no, you're not allowed to do these actions. I'm not going to let you. So if we do the same who am I all inside our PS Remoting session, we can see that we are running as admin, so we're a member of the administrators group, but we also have this anti-authority network group on there. So that denotes that we're running on a network logon, not an interactive one. So that's how it knows, hey, you're not allowed to use this particular resource, even though you're an admin. So how do we avoid this? The simplest thing that I've seen people use is use something like psexec. So in this case here, we have psexec, and this will run as system to run the same command that we have on here. So let's run this snippet. So things work just fine. We get our false back, but we have a whole bunch of red text because psexec likes to put its status output onto standard error. So we're going to have extra code to sort of extract that data out and making sure we're getting the value that we want. PSExec also doesn't come with Windows, so if you're stuck with stuff that's only on Windows, that's not going to be a viable solution for you. And I've also found that a lot of security teams don't like PSExec for good reasons. It's not that great, doesn't have great auditing, but you'll probably get a call from your security team if they're on the ball and they're checking these things. So a nice way to get around this, technically it's not built into Windows, you do need a script to do it, but it doesn't require any third-party executables or DLLs or anything like this. This is just a plain script that I've written. I've got this thing called new scheduled task session. And what this one does here is it will set up a scheduled task. It will run at either a system as the same user as a batch logon or with explicit credentials, and that's able to run something that's not a network logon. So in this case here, I'm going to pass that script in because it's just located locally. I'm going to load that in, and that will contain a new scheduled task session. This session object here is a PS session object. I can pass that in through invoke command, and then inside that one there, I can run the code that I want. Finally, I clean up that session, so it just sort of closes that process. So if we run this command here, that will go through our SSH logon that has the network token, and then inside that one there, it will run it inside the scheduled task process, and we can see that we get false back. The benefit of this one here, rather than using the start scheduled task commandlets, is one, you can pass it in through a script block, so you don't have to use files to embed your data. You can do arguments. You can easily get those complex objects back in without dealing with all that, how do I start this task, what do these commandlets look like, and so on. If we look at the who am I output using the same thing, so we're doing the new scheduled task and we have who am I all. If we look at this one here, instead of having that network logon group, we'll have the batch logon. So if we look at this one here, we now have anti-authority batch, and that's enough to bypass those deny checks on the Windows Update API. Another problem that I've seen is around credential delegation or the double hop issue. So this is when you're running on a network logon, but using authentication like Kerberos, that isn't able to then reuse those credentials to access things like file servers. So in this case here, I have a domain controller, and then I'm just getting the Windows folder for that one there and getting the full name. So if I run this one here in PS Remoting, we can see that we're going to get an access denied error. If I was to run that one locally as the exact same user, it works just fine. So that's that double hop credential delegation problem that we have here. So we can do the same thing with that scheduled tasks function that I have here. So we're going to create a target credential. This case is going to have a user that I have locally. I'm going to pass that one into the function using the using one, and I'm going to create a scheduled task session that's backed by those credentials, which then runs that same code. So it's going to get that item and the full name. So if I run this code here, we can see that when it eventually returns, we'll have that full name and no errors from that one there. So we've not bypassed that delegation issue, but we found a way to provide those credentials downstream without dealing like map drives or anything like that. We can even use this to abuse a function in Windows to spawn interactive programs from a network logon. So in this case here, I'm logged in through RDP and I have a physical desktop to show something. If I copy this and go to my host here, if I open it, I'm running in PowerShell. Let's get our Kerberos credential. Open up PowerShell. And if I copy and paste this one here, all this is doing is it's using SSH remoting to that Windows host that I have on there. I'm going to load that scheduled task function. I'm going to create a scheduled task running as interactive. So this is saying run whether user is when user is logged on. And then what it's going to do is it's going to start PowerShell on an interactive session. I'm going to show who am I and then just a message on there. So I'm just going to run this one here. That is going to return. Hopefully it doesn't error, which is great. And then we look here, we now see a PowerShell process window. Sorry, I can't make this one bigger because it's the old con host. But this is the new PowerShell process that's opened up on my interactive session rather than that isolated network one. So it's not that great because you do need to have a network logon on there, but it shows you how you can use those scheduled task features to achieve something that might be harder in normal use cases. Finally, the last option or the last issues that we had here was around how to run stuff as other users. So as I was showing before, we can use PSExec to run something as a system user. So the server 2025 is my host name. That's just how it appears on a network authentication because that's running as the actual host itself. If we load our scheduled task session, we can also use a scheduled task running as system. So we're creating our system session. We run invoke command using that PS session, and we can see the same thing. We get server 2025 back as a string. You can run new processes inside this script block here, whatever you really want to do. Finally, we clean that one up here. Another fun one that I've sort of needed from time to time, Pester version 3 is included in Windows, and I really like to use the latest version. Trying to delete version 3 is a massive pain. It's protected by the TrustedInstaller user. You either have to blow away the ACLs and set the owner and all that type of stuff. Why not just run something as TrustedInstaller and delete it that way? So in this case here, I've got another function. What this one does here, I've got to load that function in. I'm going to start the TrustedInstaller process or the service and get the process ID from that one there. I'm going to create a PowerShell remoting session that is a child of that process. So because it is a child, it's able to inherit that same username, all the groups, that access token that's running as that one there. So this session here is running as TrustedInstaller. I can then, well, as an example, we'll just do invoke command. So you can see the output here. Technically, it is running a system, so that's the user that you're running as. But the trusted installer is a special NT service group. So we can see that our who am I output has NT service trusted installer on there. So now in this invoke command session, I can do something like remove item and remove that folder without dealing with the ACLs and owners and all that type of stuff like that. If you didn't want to do that in the actual, like non-interactively, you can do it in an interactive way. So it's a bit simpler where you start up that process. It uses a module that I've written called Process X, which gives you a few extra features like running something with a custom parent. But it's also going to use this enter PS host process. So I'm going to open up PowerShell, make this a bit bigger. We can see that the process ID is 10864. So I'm going to paste that code in here. I'm going to do enter PS host process with our new child process that we've started. And we can look at the PID. We can see that we're running as 3652. We look at our who am I output. We're running as system, and it'll have our trusted installer. And we can do the same thing. We can do remove item, see program files, Windows PowerShell, and so on. I've already deleted it, so I can't actually show you that example here. But that's just running as trusted installer, and you have an interactive prompt here to do whatever you want as that user. So we'll exit that session, and that's essentially it. As I was saying, it does use that custom module for myself. So you can't do it using the built-in Windows stuff without writing a lot of code, but it shows you how you can use these PS sessions to easily send code that you want to run, any arguments, get objects back in a rich way rather than dealing with strings, JSON, and all that type of stuff. So that was the demo, and that's it. Thank you everyone for listening. We have a bit of time for questions, so yes. I need to upload it, but yes, it will be in the PSConf GitHub. I'll also include those, the new scheduled task session script and the process one. The scheduled task session doesn't require any dependencies. That will work as is, but the process session one that I did for the trusted installer does require that process X module, so it does need a third-party thing. Cool. All right. Silence is golden. If you have any other questions and you wanted to think of it later and ask me, I'll still be around for the end of the day. So thank you very much for listening. I really appreciate everyone being here on the last day and having a full house as well. That's fantastic. So thank you, everyone.